Okay, so in today's lecture, I'm going to introduce a new type of uh, device, which has not been studied in this lecture. So, a new class of device is bipolar junction transistor. So, previously we have investigated the electrical characteristics of PN junction diode as well as the MS junction diode. So basically, we have used two different reasons. For example, in case of PN junction diode, we have used the P-type and N-type silicon semiconductor materials. How about MS junction? Yes, better than semiconductor. That's it. Even though N-type semiconductor or P-type semiconductor. So whatever the type is, anyhow, it is semiconductor. So we can say that matter and semiconductor, those two different materials has been used to combine and build up the Schottky diode or ohmic junction. But from now on, what about we extend out PN diode with one more PN junction? I mean, let me write down and draw it. So we have a PN diode and we have one more PN diode, and let's combine them. Then we may imagine this PNP junction. So since there is two different junctions in this PNP, so we can call it bipolar. Bi indicates, this bi indicates meaning two, right? So bipolar junction, we have bipolar junction. And the next follow-up question is, what is the main role or function of this PNP? Well, the answer can be found in this name, transistor. So basically trans register, so transfer plus register. So it's kind of a variable register. So how to vary the resistance value of this bipolar junction device, such as PNP device? Yeah, that would be the main topic that we are going to learn in the upcoming weeks. Okay. So as a kind of extension of PN junction diode study, so it's a good timing for us to move forward to look at and study some more great details on PNP device. Definitely, as it's a complementary option of PNP, we can come up with the NPN device as well. That's true. So definitely we are going to take advantage of using it in rear integrated circuit chip. But anyhow, just to have all of you easily understand and smoothly extend out the things that we have learned previously to be well used to understand and figure out the physics and fundamentals and working operational principles of PMP device. Okay. All right. So as the first lecture note, I'm going to briefly introduce what the BJT, bipolar junction transistor. Actually, we have done it, right? Two PN diodes are connected in series, then we can build up the PNP, bipolar junction transistor. So we're gonna study some more device physics within the within BJT. Okay. So the corresponding chapter for these contents is chapter 10 in Beer's book. So please have your own time to read out all the sentences in chapter 10. Please do that. I know you're super busy, but please take your own time to read all the sentences in chapter 10. Okay, so as an introduction, let's take a look at the sentences given in this lecture note. In recent decades, actually 20 or 30 years, or I would say in 1960s to 1980s, bipolar junction transistor was the mainstream uh, in the field of integrated circuit device. However, after 1980s and beyond, maybe from now, MOSFET, we're going to study it later. Metal oxide semiconductor field effect transistor. This is another type of transistor. Anyhow, this MOSFET has been well received. It's great attention and well adopted in a modern integrated circuit chip. Okay, so most likely you may have lots of opportunities to study the basics and fundamentals of MOSFET, but you may not have a chance to study the working principles of BJT. But I guess since you have well geared up with fundamentals and device physics within a PN diode, so it's a good time to extend out your knowledge toward the working principles of BJT. Okay, so in recent decades, maybe 2 or 3 decades from now on, the higher layout density and low power advantage of CMOS technology has eroded the BJT's dominance in integrated circuit products, such as DRAM, NAND, flash memory, CPU, and GPU. That's true. Actually, if you have any chance to work in a foundry company such as Samsung Electronics Foundry Division and TSMC and Global Foundries in America, or maybe in South Korea, DB High Tech is another one, and Key Foundry, which was previously Magna Chip. There are many top ranked foundries global. Anyhow, currently, a foundry company has tried to release a new technology that should be maybe with a 99% probability that should be the CMOS device. Okay, so BJT is running behind the recent new trend of integrated circuit device, but that's okay. That's a we're gonna study, but to gear up and to have your knowledge more robust, to understand and to come up with a new class of new devices for integrated circuit chip, then I guess, and I'm 100% pretty sure that you should understand how the BJT is working. All right. So as described here, the higher layout density and low power, that those two benefits obtained from CMOS devices would be the main key point why BJT has been running behind. Okay, so higher current density or higher circuit density, or I mean the number of devices in IC chip for a given area. Definitely for the same chip area, if you place more number of devices in a IC chip, then definitely you may expect a better system performance. That's very straightforward. Okay, so for a given chip area, if you plug in more number of transistors, which would be the BJT or which would be the MOSFET, any type of transistor can be integrated together for a given area or for a limited area, then you may expect a much better system performance. Even on top of that, a low power consumption is a main benefit compared against BJT. BJT is basically, it's you know uh, the other aspect of low power consumption means, you know, its performance would be slightly worse, right? In engineering, two things cannot be achieved together. So low power application or low power thing is really nice, then definitely the other one, such as performance, would be wouldn't be very good. Okay, so CMOS technology can give us a key benefits. Number one, higher layout density. Number two, low power consumption. However, in terms of device performance, more specifically in terms of how much current can be flown for a given voltage, BJT is way better than the CMOS device or MOSFET. Okay, so in that sense, uh, for some applications, maybe the analog circuit usually, BJTs are still preferred option and preferred devices in IC chip. So why? Why still BJT is a still good option for some certain limited application of IC chip, such as RFIC, analog IC, or power management IC, PMIC stuff. How come the BJT are still preferred option by circuit designer? Yeah, the answer can be described here. Let me see, where's my pen? Here. The main, oops, once again. Yeah, the main reason has been described here. Uh-oh. Once again, I guess, why is that? Sometimes this application program is not working correctly. Uh, okay, okay. Anyhow, yeah, let me. You can see that my cursor, because of their high speed and superior intrinsic gain. So in terms of speed and gain in maybe in amplifier, BJT based amplifier can give us much high gain compared against MOSFET based amplifier. So in terms of designing amplifier, BJT should be the better option if you would like to increase uh, the gain. Oh, you know the gain, right? For a given input signal, you'd like to have some uh, amplified or improved on that. What would be the good word? Um, just you want to increase the amplitude of the signal after bypassing the input signal into the your amplifier. Then how much gain can be obtained? Yeah, in that sense, BJT is way better than MOSFET. Okay, so because this BJT can flow more current, the switching speed, all the IC chip consists of a resistor and capacitor. So it's a kind of a series connected RC networks. So for a given, voltage, if you would like to implement a high and more, more faster switching speed, then definitely you should do good job in charging and discharging the capacitor connected in those series connected RC networks. So for that purpose, we need a more current. So if your device can flow more current, then it is more likely to charge and discharge the capacitor for a very limited time with for a very limited time. Okay, so that is a main advantage of using a BJT. However, definitely there exist disadvantages of using BJT in IC. So what was it? Yes, larger power dissipation. Okay, so in terms of power dissipation or power consumption, MOSFET is better option than BJT. Okay, so because of this technical issue, so circuit designer uh, has well defined and well limited the total number of BJT devices in a circuit chip, usually 10 to the 4 transistors per chip as a basic guideline. If you'd like to plug in more number of BJT into the chip, then maybe you should get uh, you should get a discussion and permission from your boss or from your customer. Okay, so I guess that's for that's very simple introduction for BJT. And I guess I have a technical issue on my laptop, so I'm going to temporarily I'm going to stop my first movie clip on BJT, and let's discuss more and let's move forward some very fundamental words and definitions to be used in BJT. So see you in the next movie clip. Thanks. Bye bye.